what is substitution reactions, what are the different types of the substitution reactions, and we have discussed the theoretical substitution reactions and the mechanism of the theoretical substitution reactions. Isn't it? So today we discuss the nucleophilic substitution reaction. Nucleophilic. Nucleophilic substitution reaction. So what is nucleophilic substitution reaction? You know. Okay, when a substitution reaction initiates by a nucleophile, when a substitution reaction initiates by a nucleophile and produces a new product, then that substitution reaction is known as nucleophilic substitution reaction. Okay? When an organic reaction is substituted by the other atoms or group and form a new product, that product is known as substitution reaction. Reaction is known as substitution reaction. Now, we have different types of substitution reactions. Theoretical substitution reactions, nucleophilic substitution reactions, then electrophilic substitution reactions. So, now we will discuss the nucleophilic substitution reaction. So nucleophilic substitution reaction is what? So when a substitution reaction is initiated by a nucleophile and form a new product, then that substitution reaction is known as nucleophilic substitution reaction. Okay. Now there are two types of nucleophilic substitution in the code. That is SN2, SN1, and another also is there, the SNI. SNI is not university, but SN2 and SN1. So here S, capital S, and capital N in the pairs, and 2 not there, 2 is there. So what is the meaning SN2? 2 stands for bimolecular, N stands for nucleophilic, S stands for substance. That means SN2 means bimolecular nucleophilic substitution reaction. Bimolecular nucleophilic substitution reaction. Then SN1. SN1 means what? It is 1 stands for unimolecular, N stands for nucleophilic, S stands for substitution. That means unimolecular nucleophilic substitution reaction. Unimolecular nucleophilic substitution reaction. Alright. So what is SN2? Bimolecular nucleophilic substitution reaction. And what is SN1? Unimolecular nucleophilic substitution reaction. Now the meaning of SN2. When the rate of the nucleophilic substitution reaction depends on the concentration of both the reactant and reactants. Concentration of both reactants and reactants. Then that nucleophilic substitution reaction is known as SN2, bimolecular nucleophilic substitution reaction. Similarly, SN1, when the rate of the nucleophilic substitution reaction depends only on the concentration of reactants, independent of the nucleophile. Then those nucleophilic substitution reactions is known as unimolecular nucleophilic substitution reactions. Understood? Okay. Now, examples of SN. Examples of SN. Suppose methyl bromide plus potassium hydroxide. What is the product? Methanol plus potassium ethanol plus potassium bromide. All right. So this is substitution reaction. No, bromine substituted by OH. OH. So here, which one is the nucleophile? Which one is the nucleophile? This OH. This one is nucleophile. This is the reactant. Okay. Now this is bimolecular nucleophile. Why? Because the rate of these reactions depends on both the concentration of reactants and the concentration of the nucleophile. The rate of the reactions depends on both the concentration of the reactants and nucleophile. That's why it is bimolecular nucleophilic substitution. Okay, so how the reaction proceeds? How can we know that the rate of the reaction depends on both the concentration of the reactants and nucleophile? Okay, so then we have to study the mechanism of the bimolecular nucleophilic substitution reactions or SN2 reactions. SN2. So you write here methyl bromine. Okay, methyl bromide. Methyl. So nucleophile. Yeah. Now the bromine is more electronegative. So the bonding electron pair attract across the bromine. Okay. So this carbon develop for this carbon. So this nucleophile is what? Electron rich species. Okay.